In this section, we're going to discuss defining methods. A method has to have a header. If anything about this header is incorrect, the compiler will complain and throw a syntax error. The programmer, when writing a method, determines that return type. A method call or invocation is an expression. It has a type and a value. It has a name. The name is used when we want to call that computational method. We specify it by name much as we would any variable. The distinction is that we have a parameter list, which is the third point here. Now this says an optional set of parameters. These are the input data. With our f of x notation, the x is the input data. Here, although it says a method must have and it says optional set of parameters, the parameters are optional, but not the parentheses that specify the parameter list. The distinction between a variable and a method is that set of parentheses after the identifier. A method needs to have a body, otherwise why have a method? The body is the code that does the computation or the function we care about. It implements an algorithm. An algorithm is a set of steps that accomplishes a solution to a problem. If we're returning a value, we must have a return keyword followed by an expression. A header may have optional access modifiers, but must include 1 through 3. The header must be unique within a program. Duplicate definitions is the syntax error. There's a type of method called an overloaded that looks a lot like an existing method, but there's a subtle difference. That will be explained later. In math, a squaring function would be defined as square of x equals x squared. Here I didn't use the f terminology. I actually named my function. So I'm not talking about functions in general, but a very specific one here. That's what it would look like in math. Since math is the basis for functions and methods in programming, they should look very similar. The square method would look like int square, int x, curly brace, return x times x, curly brace. The major difference between the mathematical view and the programming view is the type information. If you took the int out in both places, it would be very, very similar. Now notice I don't have an exponentiation operator. I just take x and multiply it by itself. In mathematics, we often analyze a function by looking at its graph. The square function would describe a parabola opening upward. In programming, we often just use specific results and we don't care as much about graphs. Let's talk about the absolute value of an integer. The method could be written as int abs paren int n, and n is our input data, then the body in the curly braces. We say if n less than 0, that is, if n is negative, return the negation of n. Absolute value always returns a non-negative value. So if our input value is negative, we give it its negative, so a negative negative is a positive. We would return the magnitude or the size of n, which is always non-negative. Otherwise, we just return n itself. The way this is laid out takes into account the fact that the number 0 is not positive or negative. This code takes positive and 0 values and just simply returns them. The method's type is defined as int. Its value is computed as either n, which was the input value, or negative n. So those are the only two values that get computed and sent back to the invoker. That is, the expression is resolved to a type and a value. The value is either n or negative n. The value is returned, or the expression is resolved to its value by the return keyword. The return keyword is followed by an expression. It is the result of that expression that becomes the value of the method.